4. Okay, so multinomial naive Bayes. Another useful example is multinomial naive Bayes, where the features are assumed to be generated from a simple multinomial. Multinomial meaning more than one class, so more than two class, right? Binomial, class. Now we have more than one, more than two classes. Okay, so multinomial distribution describes the probability of observing counts among a number of categories, right? More than two, of course, right? So thus multinomial naive Bayes is the most appropriate for features that represent counts or count rates, right? So let's see. Let's look at this example of classifying text. Okay, so one place where multinomial naive Bayes is often used is in text classification, right? Text classification, where the features are related to word counts or frequencies within the document to be classified. Right? So, okay, let's see. Let's see. I'm going to download this data set. It's a 20 news groups for a data set, right? This one. So, you can see here there is a news data set. Okay, a news or like news articles, right? The news articles are like your data news and kun category news. Atheism, right? Graphics, computer graphics, right? Computer operating systems, right? MS Windows, miscellaneous, right? So you see, so different categories also. News go, there will be categories. Those are levels. Say levels, so targets, target names, right? So labels, so, and then you have these labels. Okay, so we have 20 of them, right? There are 20 of them. These are labels, right? So, and then, so let's look at this. We don't need this, right? 20, this sort of category. So we just take 4, right? And it's our category. Yeah, example. We'll just take data that have just these 4, right? It's our categories, right? Talk, religion, miscellaneous, social religious question, right? Science, space, and computer graphics. Okay, so let me this much case you train the test time download right? You train data download and test data download, right? Then okay, so that's what we do here. Okay, you I'm going to train or test way I am. Okay, after that let's go about keys area. Let's see, you see, you basically your train. This is a dictionary, as a dictionary form. So let's go. Okay, let's go keys area. Data, sir, file names, sir, target names, target description, sir. Right? Let's go target names. Train. You train. You train. Download. Let's go. If you look at target names, exactly. I'm using the computer graphics, science, space, social religion, Christian, talk religion, miscellaneous. Hey, you started. I'm taking it. I'm download. That's exactly what we see, right? Give these 4 target names, right? And data how many? Data set, right? Train data. There are 2,153 data. Okay. And this say your data print. So let's say with this month, we'll just print one data. Your data print, as you can see, understand? So right? So and there are number of lines. So this is the text. Right? You say text or news, whatever. Right? You say news or isko news ko, right? Isko level kita. You go isko you kun category of person. Factory rumor. Madeline Murray's here an atheist who eliminated the use of Bible reading and prayer in public schools 15 years ago is now going to appear before FCC with a petition to stop the reading of the gospel. Whatever. So okay, yeah, it should be a religion, of course. Use of computer graphics money, why not? Of course, I'm the space why not computer graphics, your data either you right? Okay, so let's see what it is. You target you data 5 and 5, right? So it's a target, targeting 3, right? Target 3, 3 when you see, we could say 0, 1, 2, 3. When you see talk religion, right? Okay, talk religion that miscellaneous, right? So you say talk religion, right? You could have did you guys understand the the nature of data? Dixon?
Yes, sir.
Okay, now, okay, very good. Okay, now what do we do? So we got ready, we got the data, training and test data, both are ready. Right? So in order to use this data for machine learning, we need to be able to convert the content of each string into a vector of numbers. I did this, and as we said, feature engineering data. So I mean, for machine learning, we need to convert the text data to what? To numbers. And let's say number, we need to convert those to numbers. So for that, we'll use TF-IDF vectorizer, which I explained before, right? Okay. For this, we'll use TF-IDF vectorizer and create a pipeline that attaches it to a multinomial naive-based classifier. Right? So I'm going see we are import right? TF-IDF vectorizer, multinomial naive-based big pipeline. And when we see your data the pipeline, we're creating this pipeline. Right? With your pipeline, okay, let me quickly show you how that pipeline works, how that how it works. Okay, so pipeline there are two things. Okay, what are they? Pipeline okay. TF-IDF, okay. So first yeah, TF-IDF vectorizer. Vectorizer, अनि त्यसपछि त्यहाँबाट त्यसबाट गएको आउटपुट यहाँ यो इनपुट भइहाल्यो है अनि केमा जान्छ yes, that's right, right? Multinomial naive base, right? Naive base मा जान्छ. Okay, so okay, so this is our pipeline, है यो हाम्रो pipeline. Okay, so this is our pipeline. Okay, pipeline. Okay, so you can see the pipeline, right? Now let me run this. Okay, have I run all of these out there? So anyway, so you probably run by seconds, so I don't have to quite worry about that, right? So anyway, just let me run all of them. Okay, so okay, right here, where are we? Okay, so yeah. All right, so okay. So right here, right? So with this pipeline, we can apply the model to the training data and predict levels for the test data. A model. This is our model. Right? The whole thing is the model. Right? Your pipeline of your model. Right? So this is the model. Okay, and your whole thing is one model. Right? As a whole, we can take it as a whole. This whole thing is our model. Okay, the whole thing is our model. Okay, above your model ma हामी के गर्छौं train.data train.target है हामीले के दिन्छौं data र target है data level है so we'll fit है यो गर्दाखेरि हामी training भयो हैन we train अनि हामी त्यसै test मा हामी test हैन we give predict गराउँछौं है predict गराउँछौं test data दिएर है which is the standard thing right? So you by now you guys are very much familiar with this right? And यसले चाहिँ levelहरु दिन्छ है यो चाहिँ के हो predicted levels right? These are what? These are predicted levels right? Okay, now that we have predicted the levels for the test data, we can evaluate them to learn about the performance of the estimator right? It's not some kind of confusion matrix. Confusion matrix have we covered? Confusion matrix.
Yes, sir.
That's right. But if we see ISMA, okay, can you interpret this based on what you know? This is the confusion matrix. ISMA is the let's go true level computer graphics. Okay? Computer graphics, how many of them it predicted correctly?
330, 340.
344, yes. Again, so this is correctly predicts. त्यो मध्ये हैन 13 वटालाई उले के भने साइज स्पेसमा राख्यो है प्रेडिक्ट गर्दियो त्यो मध्ये 32 वटालाई हैन सोशल रिलिजन क्रिश्चियनमा राख्दियो है which is quite strange है कम्प्युटर ग्राफिक्स त्यसो खासै I mean हैन so okay so because multinomial is a naive base so I mean it's not so we cannot expect top notch performance हामीले expect गर्न सक्दैन because it's a naive base basically multinomial naive base but it was still not bad. Give me so the fact of the matter is so it's done overall. The major percentage I mean is you correct classify गरेछ नि हैन अब यता उता गाछ of course misclassification छ तर correct classification percentage बढी छ हैन so त्यसले गर्दाखेरि for this simple model it has done a good job. Hey, overall it has done a good job. Hey, but here just the isma say isma के problem भन्दाखेरि say talk religion miscellaneous. Okay, isma चाहिँ problem देखियो नि त अब यसमा के देखियो so what is the problem here?
धेरै लेभलहरुको चाहिँ incorrectly predict गर्यो.
Yeah, that's right. So 187 लाई उले incorrectly predict गर्यो है 48 चाहिँ ठीक छ हैन 187 लाई it's a huge हैन huge amount एकदम lot of data यसले के गर्यो भन्दाखेरि यसले misclassify गर्यो तर I mean but तर केमा उले चाहिँ के सम्झ्यो भनेपछि ट्रु लेभल चाहिँ हैन टक रिलिजन मिसलेनियस तर उले चाहिँ के प्रेडिक्ट गर्दियो सोशल रिलिजन क्रिस्चियन हैन भनेपछि अब इट्स नट अनएक्सपेक्टेड के मतलब यो हैन जस्तै हामीलाई गाह्रो हुन्छ हामी ह्युमन्सहरुलाई गाह्रो हुन्छ मसिनलाई गाह्रो नहुँदा कुनै पनि हैन हामीलाई त त्यो अब यो दुईटा मध्ये कुन हो छुट्याउन गाह्रो हुन्छ नि अनि क्रिस्चियन दुवै रिलिजन हो नि त रिलिजन क्रिस्चियन रिलिजन मिसलेनियस है ओके so I mean हामीलाई even human like गाह्रो हुन्छ भनेपछि त हैन so machines have also a hard time so त्यसले गर्दाखेरि हामीले यसलाई त्यति दोष दिन मिल्दैन है so I mean still not bad okay so see you can see that okay evidently even this very simple classifier can successfully separate space talk from computer talk but it gets confused between talk about religion talk about Christianity right? Perhaps expected area of confusion is here right? As is expected of course right? Okay, let's see. What's this? Okay, we can give our own, our own text. And we text there. We can make it predict. You see, sending a payload to ISS. And it's a good text. Still, it can predict that model. Right? Your model, say, your function, so your function, right? It returns a prediction. As they slide. Size space which is good, right? Sending a payload to ISS, International Space Station, means of course it is bound to be space. When you see, I mean, it's such a simple model, but you understand, it's just nice classification, exact classification view, exact correct answer view. That's the estimate. Discussing Islam versus atheism. Okay, you got that, of course, social religion, Christian, right? All right, maybe this might be maybe this one, right? Talk religion miscellaneous I don't know. Okay. I'll just say determine screen resolution and computer graphics, right? Evidently, right? So essentially, it does a very good job overall, right? Okay, so your baseline like it's a very good right? Baseline, right? Baseline model, right? All right, so remember that is nothing more sophisticated than a simple probability model. For the weighted frequency of each word is in the string, and over this, the result is striking. Okay? Even a very naive algorithm, when used carefully and trained on large set of high dimensional data, can be surprisingly effective. Right? And then you can read this part. Right? Okay. All right. So basically, now naive base, which is nice. First thing here, it's a simple, right? Simple algorithm, and then but it still works nicely, right? Acceptable level. You can, we can use it as a baseline, right? Baseline model sort of like, right? So this is naive base. Okay, any questions so far? Then probably we can proceed with the chapter. What do we have here? Right? Okay, linear regression. Right? Let's try this. So. Okay, so linear regression, right? So just as naive phase is a good starting point for a classification task, right? Linear regression also is a good starting point for a regression task. Hey, see, naive basically what? Classification, right? So it worked really well for classification. But how about regression? Right? So regression similarly, right? You're a simple algorithm, so linear regression. You're a baseline, right? You can do a very good baseline with linear regression. linear regression for regression models, regression. Okay, for regression tasks. These models are popular because they can fit very quickly and very interpretable. Right? You're probably okay. So let's start here. Let's see, it's a standard input value. Rather, I'll run all the cells. So somebody run question. Okay. Okay. Well, simple. Okay, let's look at simple linear regression. Simple linear regression में के हुन्छ भन्दाखेरि तपाईको जस्तै यो त हामीले धेरैचोटि गरिछौँ है अब यो जस्तै तपाईहरुलाई इन्टरभ्यूहरुमा हैन सो तपाईहरुलाई धेरै यस्तै सोध्छ कि तपाईको बेस नलेज कति छ तपाईहरुको हैन तपाईको हैन डीप न्यूरल नेटवर्क्सहरुको त्यो सोध्दैन हैन I mean they want to know, right? Interviewer के सोध्छ so what they want to know is, do you know your basics? Do you know your fundamentals? Okay, so most of the time, they ask these kind of questions. In linear regression, right? They already started, see, linear most machine learning interviews are okay. How well you know your linear regression, right? Because that is the baseline. That is the fundamental core, right? So you need to know your concept for example, see. So linear regression. So y equal to mx plus b. When a linear regression, you linearly, linear. So regression got that, as we have done a lot of times, right? So let me erase this. Okay. So linear regression, of course. So you have some data. So you have some data points, right? There are a whole bunch of these data points, right? So your 2D map, right? This is 2D. Rather our the input is in one-dimensional input, right? Say x or y, right? Okay, say what do you do? Linear regression simply best fit line, right? Isn't that so? Right? But if it's equation Q, so what is the equation of that line? Y equal to Q, okay, all right. Y equal to ax plus b. A भनेको m, है जुन slope भयो, b भनेको के हो? What is b?
Intercept.
Intercept. Very good. Hey, intercept. Okay. All right. Y भनेको okay, let's see. Close this. Okay, very good. Okay, so this figure, you say your two-dimensional case. How about 3 dimensions? What about 4 dimensions? What about 5 dimensions or higher dimensions? Okay, still you can use linear regression. Okay, still you can do linear regression. Okay, so okay, so basement, well, let's do this. I mean, let's use uni. We could. So I won't spend too much time on it. Okay, so we just use linear regression. You we have already done it. Okay, okay. So you guys know it's S minus. It's called slope, but yeah, 2.02. Intercept minus 4.99. Right? So our true cut you. 2x plus 2x minus 5. Right? 2x minus your y equal to 2x minus 5. And you the noise. Right? This is noise, right? So we don't account for that. We don't need to worry about that. And we have a true function. Yo, right? 2x minus 5. Right? This is my parameters 2 minus 5. Right? 2 minus 5. 2 is the coefficient, minus 5 is the intercept. Right? Let's see. So we model के निकाल्यो, data बाट के निकाल्यो. हाम्रो actually कति थियो? Slope कति थियो? True slope कति थियो? 2 थियो. अनि यसले कति निकाल्यो? 2.02 अथवा 0.3 भन्यो. हैन? 2.03 भन्यो. Like 7 छ. 2.03, which is not bad. हैन? It's good. Intercept हाम्रो कति थियो?
-5.
-5 थियो. यसले कति निकाल्यो? Almost -5 किनभने 998 गर्दा राउन्ड गर्यो भने 5 नै हुन्छ. Right? Okay, 0.9985 is the sign. Effectively, it's -5 now. Right? Okay, so I mean, it did a good job. Right? So it's a simple 50 50 data. Right? it came up with the correct, very close approximation of the slope and intercept. Right? This thing we can take it to a higher dimension, right? Multi-dimensional model, like right? So we can do similar. It's like y is equal to a0 plus a1 x1, right? Right? x1. X is one dimensional. Right? Okay. About this theory, how about about x को x equal to 1 dim हुँदाखेरि है 1 dim हुँदाखेरि यसै गर्छ त्यसै तपाईको x चाहिँ 2 dim को छ भने के हुन्छ भन्दाखेरि कतिवटा x हुन्छ x 2 dim भयो भने 2 dimensional छ भने x कतिवटा हुन्छ दुईटा हुन्छ है भनेपछि now we can do a0 plus a1 x1 plus के हुन सक्छ a2 x2 हैन त्यसै गरी तपाईको x equal to 3 dimension छ भने हैन x1 x2 x3 हुन्छ हैन y equal to के हुन्छ a0 plus a1 x1 plus a2 x2 अनि plus के हुन्छ a3 x3 and so on है जति हैन this linear model still linear हो नि त there's no power छैन त हैन भनेपछि it's linear है all of them are linear यो जुमै जति पनि देख्नु भएको छ यहाँ हैन all of them are linear linear functions are right right makes sense okay so that's how it works so this we can take it to any number of dimensions right and we can apply this linear regression linear regression model okay so okay ISMA of course so geometrically this is akin to fitting a plane to points in 3 dimensions I've already shown you that right so say is the ISMA case is the your case man is the you best fit line right ISMA 2 dimension state तपाईँको यो छ 1 dimension तपाईँको input 1 dimension हुँदाखेरि के हुन्छ भन्दाखेरि तपाईँको ग्राफ चाहिँ 2 dimension मा आउँछ of course हैन त्यो गर्दाखेरि तपाईँको you get a line as the best fit अनि जस्तै x equal to 2 dim हुँदाखेरि है x equal to 2 dimensional छ भने त्यसलाई केले फिट गर्नुपर्छ 2 dimensional छ भने त्यसलाई प्लेनले फिट गर्नुपर्छ हैन 2 dim भनेपछि के हुन्छ भन्दा यो चाहिँ 3 dimensional मा जान्छ हैन अनि we have to fit a plane है plane पाता फिट गर्नुपर्छ हैन 3 dimension मा के हुन्छ भन्दाखेरि अब तपाईको 3 dimensional हुँदाखेरि तपाईको अब यो होल ग्राफ चाहिँ 4 dimension मा जान्छ किनभने including the output हैन so त्यो केसमा हामी 3 dimensional manifold हुन्छ है manifold okay त्यो बेस्ट फिट चाहिँ manifold हुन्छ है could be अब त्यो twisted complicated हुन्छ है okay so kind of making sense so far बुझिराख्नु भएको छ intuitively
yes sir
yeah okay very good all right so the multidimensional nature of such regressions makes them more difficult to visualize okay of course हैन त्यो जति हामी अब dimension बढाउँदै गयो हामीले चाहिँ त्यो visualization गर्न सकिदैन हामी अब भनौं न 3rd dimension 3 dimensions मा सकिन्छ जसमा हामी plate हैन we can plane fit गर्न सकिन्छ हैन त्यो गर्न सकिन्छ so let's see right okay but we can see one of the action by building some data okay let's see अब हामीले यहाँ के गर्छौं भन्दाखेरि let's run this right so अब यसमा यो सबै यसै भएको छ so we are creating this training data right training data अनि training level है data पनि छ र level पनि छ ल हाम्रो data कति dimension x कति dimension छ कतिवटा rows कतिवटा columns हेर्नुस् न x को 4 yes 4 columns 100 rows 4 columns 4 columns भनेपछि x कति dimension को भयो अनि x को हरेक point भनौं न x को हरेक point कति dimension 4 dimensions of course हैन हरेक point x को हरेक point चाहिँ 4 dimension को छ भनेपछि हाम्रो के भयो भन्दाखेरि अब यो x equal to 4 भयो x equal to 4 dimension भनेपछि अब यो यसको बेस्ट फिट कसरी आउँछ what's the best fit भन्दाखेरि यसको 4 dimension मा गयो भने हाम्रो बेस्ट फिट के हुन्छ y equal यस्तै हैन a0 plus a1 x1 plus a2 x2 plus a3 x3 plus a4 x4 हो ओके यो हुन्छ है यसको बेस्ट फिट यसले दिन्छ है which is this manifold यो चाहिँ manifold भयो है यो चाहिँ straight line यो चाहिँ plane अनि यहाँबाट manifold है हाई डिमेन्सन manifold है ओके many भनेको many हैन fold भनेको त्यो विभिन्न folded हैन मतलब त्यो हुन्छ होला हैन सो आई मिन त्यो हाई डिमेन्सनमा हामीले त्यो भिजुअलाइज पनि गर्न सक्दैन है सो ओके एनीवे alright so now okay so what do we do here we use we're importing linear regression right अनि हामीले we creating of course we step 1 step 2 fit intercept true गरेको छौं and then step 3 fit है अनि यो फिट गर्दाखेरि now you can see this you understand अब यसमा okay so हाम्रो y चाहिँ यसरी देख्यो हैन so this is our y right? Y is equal to 0.5 plus np dot x okay so यसमा के भइरहेछ भन्दाखेरि now I have to show you this one right so dot product हामी यहाँ dot product गरिरहेछौँ कि है dot product भनेको matrix multiplication very much like dot product को के हुन्छ भन्दाखेरि यसमा quickly show you that and let me create a new one. Okay, so it's exactly here. So we have this x which is 100 by 4. Right? X costs 100 by 4. Means let's say x1, x2, excuse me, x3, and x4. Right? Okay, it's our lesson. Okay, and then how many of them are here? What you already did, sir? Right? Okay, so this is our x, but how about y? Okay, so y ma y ma 0.5 plus np dot right extra and you right and let's say y like about y. Okay, let's see. Okay, about y ma we're trying to create y. Right, let's create y. This pen. How about y? Y को लागि हामीले के गर्छौँ भन्दाखेरि so np dot let's say so np dot np dot x right and this to say हामी के गर्छौँ भन्दाखेरि this 1.5 minus 2 1 or 0.5 okay अनि 1.5 minus 2 1 or 0.5 1.5 right so यसरी गरेको छौं है right so भनेपछि के हुन्छ भन्दाखेरि अब यो x यस्तो छ भन्दाखेरि अब यो चाहिँ यहाँ डट प्रोडक्ट है डट प्रोडक्ट हुन्छ है डट प्रोडक्ट गर्दाखेरि के हुन्छ भन्दाखेरि तपाईको एज यु नो डट प्रोडक्टको रिजल्ट केमा आउँछ डट प्रोडक्टको रिजल्ट केमा आउँछ भन्नुस् स्केलर भेरी गुड है जस्तै तपाईको x को एउटा मात्रै हो है लेट्स टेक 1 है एउटा रुल जस्तै तपाईको x1 x2 so these are actual values नै हुन्छ त्यहाँ है तर I'll just take this for now है यो र अनि यो है 1.5 minus 2 1 र 0.5 अब यिनीहरुको शेप कस्तो अब यसमा मैट्रिक्स मल्टिप्लिकेसन है डट प्रोडक्ट हुँदैछ है सो सिम्पल मैट्रिक्स मल्टिप्लिकेसन यसमा डट प्रोडक्ट भन्दा पनि अहिले चाहिँ हामीले सिम्पल मैट्रिक्स मल्टिप्लिकेसन गर्यो भने के हुन्छ भन्दाखेरि यसको शेप के छ यसले भेक्टर सम्झिनुस् यो दुईलाई भेक्टर सम्झ्यो भने कति हुन्छ 1/4 हो यतातिर कति हुन्छ यो पनि 1/4 हो इज दैट राइट है दुवै 1/4 छ अब यो मल्टिप्लाई गर्न मिल्छ त मैट्रिक्स मल्टिप्लिकेसन गर्न मिल्छ यिनीहरुको मिल्छ कि मिल्दैन मिल्दैन किनकि यो मिल्नु पर्छ नि त मैट्रिक्स मल्टिप्लिकेसन गर्न त इनर डाइमेन्सन्स मिल्नु पर्छ नि त यो मिलेको छैन भनेपछि अब यसबाट यो दुईटा मल्टिप्लाई गर्दाखेरि स्केलर आउनलाई केलाई एउटाले ट्रान्सपोज गर्नुपर्छ कुनलाई ट्रान्सपोज गर्नु ए लाई कि बी लाई यसलाई ए भनौं यसलाई बी भनौं है कुनलाई ट्रान्सपोज गर्नुपर्छ ल भन्नुस् त ए लाई ट्रान्सपोज गर्नु हुन्छ त्यो 4/4 आउँछ नि त फेरि ए लाई ट्रान्सपोज गर्यो भने त 4/1 र 1/4 रिजल्ट के आउँछ 4/4 आउँछ नि त मिलेन नि हैन सो केलाई ट्रान्सपोज गर्नु पर्यो
एलाई
एलाई कि बीलाई
बीलाई बी
बीलाई गर्नु पर्यो नि त अफ कोर्स हेर्नुस् त यो 1/4 छ बीलाई ट्रान्सपोज गर्दा यसको के हुन्छ 4/1 हुँदैन हुन्छ है ओके यो दुईटा मिल्यो नाउ वी क्यान मल्टिप्लाई रिजल्ट के आउँछ 1/1 को आउँछ नि त मैले भनेको कुरा बुझ्नु भयो
यस सर
So, अब यो I'm trying to show you why we're doing dot product. यो dot product किन गरिरहेको छु dot product ले गर्छ कि dot product ले के गर्छ भन्दाखेरि अब मैले यसमा यो दुईटामा डट गर्यो भने मैले चाहिँ एक्चुअली गर्ने के भन्दाखेरि यो है मैले यो दुईटालाई मैले यो दुईटालाई डट गर्दाखेरि हैन यसलाई डट गर्दाखेरि यसले के गर्छ भन्दाखेरि अनि यो सेकेन्ड जुन जस्तै तपाईको भेक्टर यो फर्ममा छ है रो भेक्टर फर्ममा छ भने चाहिँ तपाई के गर्छ भन्दाखेरि यो जस्तै त्यस्तै राख्छ यसलाई चाहिँ के गर्छ अनि यसै है 1.5 -2 1 र 0.5 whatever है सो त्यो छ हैन अनि अब चाहिँ के भयो अब यो र यो मल्टिप्लाई गर्न मिल्छ है अब यसको रिजल्ट के आउँछ ल भन्नुस् त व्हाट इज द रिजल्ट यो दुईटा मल्टिप्लाई गर्दा मैट्रिक्स मल्टिप्लिकेसन
x1 into 1.5 plus x2 into -2
okay -2
x3 into 1
times
plus x4 into 0.5
very good है यसो यो फर्ममा आउँछ नि त हैन सो रोज यो रो र कलम मल्टिप्लाई भन्यो नि त हैन सो सिम्पल मैट्रिक्स मल्टिप्लिकेसन त भन्यो हैन सो यसलाई मल्टिप्लाई गर्छ प्लस यसले मल्टिप्लाई गर्यो प्लस यो मल्टिप्लाइड बाइ यो प्लस यो मल्टिप्लाइड बाइ यो हैन सिम्पल के हो मैट्रिक्स मल्टिप्लिकेसन हो नि त हैन अनि यसबाट एउटा नम्बर आउँछ हैन एउटा नम्बर आउँछ यो तपाईले अब यसमा नम्बरहरु राखेपछि अफ कोर्स हैन सो स्केलर आउँछ है सो अब एनपी डटले गर्ने काम त्यही नै हो है एनपी डटले गर्ने त्यो भनेपछि यसले चाहिँ के दिन्छ भन्दाखेरि अब तपाईले यसो गर्दाखेरि के हुन्छ भन्दाखेरि तपाईको y के फर्ममा आउँछ भन्दाखेरि हरेक जुन रो छ हरेक रोमा चाहिँ के हुन्छ भन्दाखेरि अनि हरेक रो इज डटेड विथ दिस भनेपछि कति हुन्छ यो हरेक y चाहिँ अब y को शेप अब के फर्ममा आउँछ व्हाट्स द शेप अफ y यो चाहिँ 100/4 को छ भनेपछि y को शेप के हुन्छ
150/1
150 100 हैन 150 त कहाँ हुन्छ हैन 100/1 को हुन्छ है y को शेप ओके हैन सो हरेक रो को लागि एउटा स्केलर भ्यालु दिन्छ नि त ओके सो बेसिकली
150 लेखेको जस्तो देखेर
Yeah, पहिला okay, I see. Okay, yeah, say sorry. Okay, anyway, so yeah, I get your point. Anyway, right? So 100. Okay. So anyway, so अब यो के भन्दा हरेकलाई के गर्छ भने हरेक रोलाई चाहिँ है हरेक यसको हरेक रोलाई के भन्छ भन्दाखेरि यही अनि गरे जस्तो है 1.5 times x1 plus -2 times x2 times 1 times x3 plus हैन 0.5 times x4 है त्यसको जुन रिजल्ट हुन्छ त्यही y मा आउँछ है किनभने यो त यहाँ सबै यहाँ त नम्बर छ नि त है ओके सो नाउ अब त्यही यो भनेको के हो भन्दा दिस आर प्यारामिटर्स जुन अघि हामीले गर्यौ नि हैन सो हामीले a0 plus a1 x1 plus a2 x2 plus a3 x3 plus a4 हैन x4 हैन यो थियो नि इज दैट राइट है y is equal to हैन अब यसमा हामीले इन्टरसेप्ट फल्स गरेको छौं है सरी ट्रू रहेछ इन्टरसेप्ट ट्रू छ भेरी गुड इन्टरसेप्ट ट्रू छ भनेपछि अब हाम्रो यो अनुसार चाहिँ हाम्रो a0 के हुन्छ यो हुन्छ हेर्नुस् न a0 के छ 0.5 छ हैन a0 के छ 0.5 छ यसै कति छ 0.5 छ अनि a1 कति छ ल भन्नुस् हैन दिस इज a1 a2 a3 a4 हैन त a1 कति छ 1.5 a2 कति छ -2 a3 कति छ अनि a4 0.5 हैन ओके अलराइट सो अब यो चाहिँ अब हाम्रो मोडलले चाहिँ हामीले दिने यो हो नि त प्यारामिटर्स दिस आर प्यारामिटर्स हैन What are these? These are params, parameters. हाम्रो मोडलले हामीलाई parameters दिने हो नि त. Okay. Now if you go back here and then see, हामीले बनाएको डेटामा चाहिँ यो parameters छ है. हामीले यो parameters हामीले दिएको parameters हो नि 0.5 1.5 -2 1 0.5 हामीले दिएको parameters हैन. यो अनुसार हामीले डेटा बनाएकै यसरी हो हैन. अब यसले चाहिँ यो डेटाबाट यो फिगर यो parameters उले फिगर आउट गर्नु पर्यो नि हैन. उले गर्दाखेरि अब कम्पेयर गरौँ है त. उले इन्टरसेप्ट कति निकाल्यो 0.4999999. हाम्रो कति थियो इन्टरसेप्ट?
0.5.
Very close. र बाँकी चाहिँ मिल्यो हेर्नुस् त. A1 1.5 1.5 ठ्याक्कै छ होला. -2 -2 1 1 0.5 and 0.5 है. ठ्याक्कै मिलेछ. Right? Okay. So it is a very good job. Simply out, right? Okay. Let's see. Okay. All right, and then save it. 1 second. And then save it. Okay. All right. So yeah, it has done a very good job. Right? Good job. Linear regression at high dimension. Okay. So body say today is what, Thursday? Okay, body saying we'll have classes tomorrow, right? So body saying we'll do this basic function regression. Okay. So yeah, the saying of course I know so it's hard. It's maybe it's hard because it's not of course minute saying on course. Okay, minute saying on course. Anyway, so let's meet tomorrow. Okay, bye for now.